elc138 worksheet 23. Now, if we were meeting, we would be breadboarding this circuit, but we can't breadboard this circuit. Hopefully by now we would be to the point where you could breadboard it. You could set up the voltage. This is an AC voltage. So remember that 3.5 volts peak is not 3.5 volts RMS. And since I don't tell you what kind of waveform it is, assume it's a sine wave. Okay, the circuit should have a resistor half your age in K ohms. You can round to the nearest one if you'd like, however you want to do it. An 11 and a 20. The 11K is in series with the other two, which are in parallel. And run test wires as points to nodes. Have the instructor check. So by this time I would be checking your breadboarding. You're going to wind up with a node 1, a node 2, and a node 0, or the common node. One of the things I would check then would be your volts, your frequency, that you placed your resistors correctly, that you had the correct value of resistors, that you have no wiring issues, and your test points are wired such that your circuit could be covered. Okay? So that's what I typically do for worksheet 23. And worksheet 23 is a lot like worksheet 25. So it will be some circuit, but I'll probably go in and change some stuff on 25 since this is all virtual. Analyze your circuit to find all the voltage drops and the currents. So you want the current through calculated and the voltage RMS calculated. And then notice I give you peak and I ask for RMS voltage. And it's an AC circuit. Frequency 60 hertz. There are no reactive components, so it doesn't really. No, the frequency is supposed to be. Yeah. Frequency equals twice your age. Frequency doesn't matter. It matters only in setting up the function generator. It won't matter in the analysis. If you take this peak voltage and you convert it to RMS and you do standard DC analysis on it because it's all resistive, then your RMS values will be your DC values for current, voltage, and power. Okay? If you want to do the AC analysis, you can. I'll probably have to do a video on that though for the next worksheet or the end of the next worksheet. The big thing I'm looking for on this assignment, because since I can't see your breadboard, is that you create a troubleshooting chart. You have 6 components in there. You have 3 components in there. You have 6 possible bugs. So build me a complete table of 11K open, 11K shorted, 20K open, 20K shorted, and whatever your age is in K open, and whatever your age is in K shorted. And then what I'm looking for is the voltage from 1 to 0 and from 2 to 0. And all those 6 conditions and the normal. So here's the normal, and here's resistor 20K open. That's going to be one of the conditions in your troubleshooting chart. So I'll be looking for the troubleshooting chart as the bulk of the grade for this spreadsheet. And that you get your RMS value right. And that your calculations are reasonable. Okay? That one's pretty straightforward. And then I want to go ahead and start worksheet 24 in this video. Give you another circuit to analyze. This is a stop-start. It's a pretty standard circuit. It's everywhere. And so what I want you to do is record the voltage readings. Just like you made a troubleshooting chart for the last circuit, we're going to do voltage readings based on these conditions. So What I have here at the bottom are test point 1, 2, 3, and 4. And so when I do the voltage reading from test point 1 to test point 2, I'm basically looking at measuring the voltage between these 2 points. 2 to 3 would be between these 2 points. 3 to 4 would be between these 2 points. Okay, I like going over this in class. We're not going to get to, but that's okay. So as drawn is the initial state. If you were to just walk up this circuit and start measuring it, what would the values be? And if you press the start button and you held the start button, and the start button is clearly marked, so I'm pressing it and holding it, so normally open, so it would then be closed, what would my voltage values be? And then if I release the start button, assuming the circuit works, what would my voltages be? Now what you got to realize is that when you press the start button, you're energizing this coil, and that this contacts will then close. So when you let off the start button, this is still energized and this is still closed. So your readings will change. Stop, pressed, and held. What will my readings be? Stop and start, pressed, and held at the same time. What will my readings be? Okay. Then we're going to move into capacitive reactance, which probably 6 to 7 will just be a video on its own. You've got enough to do getting me a complete chart for worksheet 23, and I will come back and revisit this one at a later time beyond that circuit. If you'd like to look in the book, you can look up capacitive reactance, inductive reactance. That one we've been over, and you can see how the two formulas compare and embrace the symmetry in electrical. But I'll come back to this one, because then we're going to do parallel and everything else, and then we'll do some LT spice analysis that we haven't done before, transient, or at least set up, because we'll do a lot of that in DAC class. Okay. So this gets us through 1 through 5 on worksheet 24, and that's why I call it 24A. Thanks for watching.